go. Okay, sand slabs, it's numbers. A snapshot of the bricks, they are still falling. Oh, is it Tetris again? Disintegrate. Safe to disintegrate. Each line of the text present position of a single brick. Oh, 3 dimensions. 2 XYZ coordinates. Straight line of cubes, and now I want to choose a time. Integers positions above the ground. So the whole snapshot is aligned to a 3-dimensional cube grid. So same part, and the brick is a single cube. It lines like so and so. The 2 cubes in volume horizontally. For, okay, and so they always have the same. Yeah, they're not diagonals. I see. Okay. Both oriented horizontally. Yeah, x, y. The ground is at z equals 0, perfectly flat. The lowest z can have is therefore 1. Both resting on the ground. Was above ground at the time of the snapshot. Because now we're taking of bricks are still falling, some bricks will still be in the air. Start by figuring out where they will end up. Bricks magically stabilize so they never rotate, even in the weird situations where okay. 2 bricks cannot occupy the same position. Falling brick will come to rest upon. Yep, Tetris. Okay, at the time of snapshot, side X are lined up like that. Yep. Yeah. Again, now that all bricks are settled, because which bricks are supporting. Okay, the only bricks are. Okay, first I have to figure out which bricks are safe to disintegrate. If after removing it, no other bricks will fall further directly downward. Don't actually disintegrate a brick. And what would happen if, for each brick, only that brick was disintegrated? Bricks can be disintegrated even if they're completely surrounded by other bricks. You can squeeze the bricks if you need to. Okay, how many bricks could be safely chosen as the one to be disintegrated? Okay, let's do this. So, we have A, B equals split by tilde. Now we have 3 coordinates. Okay, how are we gonna, so I'm gonna create a hash of all the bricks and their directions, basically, because it has a, yeah, okay, so I'll just, $H, how am I going to do this? I need to keep dropping the bricks to see if there's anything, so let's mark all of, okay, so I need push A, that's put the brick in the array, and now we have our grid. So I need to get the figure out which one is the dimension of stuff. And okay, so for my A equals split by comma of A. Okay, and B, those are the 3 dimensions of each of them. And now for I goes from A of 0 to B of 0. For my J goes from A of 1 to, I know this is not the cleanest way, but this is the fastest way. K goes from A of 2, B of 2. Okay, now grid in coordinate I uh, J K equals the count the index in A where it will be. Okay, push a so and so out. This is a doozy. Okay, perl. Okay, so wait, what? A? Oh, not A. I want to look at G. How does the grid look like? Yeah. Okay. Wow, there's a lot of bricks there. That's yeah, a lot of bricks. And wait, 1388. You shouldn't have. Okay. Yeah, that's fine. Okay. So now I need to check if for every brick I need to check whether or not I can move it down, and if I can do that. So while no, I mean, for my brick in A, so brick is etc. So my A equals split by comma of B of 0 and B of 1. Okay, now again, loop on that brick and see if we can change it. So this is K minus 1. So, okay, so first of all, uh, okay, next loop unless K. That means you're in the bottom. That's definitely not okay. And next loop unless defined. I mean, if defined, that means yeah, that means it's there's something there and you can't drop. Okay. Uh, okay. Uh, yeah, so while there still has been a drop, we need to drop the bricks. Well, next bloop, if defined, etc. Okay. Now we need to actually drop the brick. Dropping the brick is as follows. What we need to do is as follows. We need to change the z coordinate of the brick. So a of 2 plus plus b of 2 plus plus. And I need to put them back. So b equals join comma a comma join comma b. This is ridiculous, but I think it would work. So that will put it back in the original array. What the new location. And when I say plus plus, I mean minus minus, of course, because the z is going down. And then I need to change g. So same silly loop. Same silly loop, but I need to, let's first delete then set, right? So, because, yeah, that might not work if it's a vertical thing, because are they all, unless they are always, yeah, here an example from low to high. Cause okay, I mean I'm putting that and let's first delete and then set, just to be safe. So first of all, g of actually like that. So let's do it like this. Equals undef. So that means make a space and then g equals oh frick. Yeah, let's not call it I, let's call it bi. Bi, and then this is bi. It's dropping a brick. Okay, and then the important thing is also if you drop the brick, then drop equals 1, so we need to do this again. Okay, let's run this and see if it takes forever. No, it does not take forever, and now the bricks are all dropped. Okay, now we need to check which bricks, go over the bricks and see if they are, if there's any brick, if they are the only brick supporting another brick. Oh, that's tricky. So instead, let's go and for every brick, find which brick support it. So I need to do another bloop like this. Another bloop. Now, uh, no, I'm not nexting bloop here. I'm just checking, okay, if net, just next this one, unless, okay, because if it's on the, well, no, if it's on the, if it's supported by the ground, nothing is supporting it, right? Yes. So next bloop, this is fine. Now, oh, bloop two. Okay. Oh, if it is defined, if there is something one that's supporting you, then h of this thing uh, of $bi plus plus. Okay, that means you are supporting brick bi. And now, okay, and now anything, right? So if you are, no, if you're the only brick supporting it, that matters. Otherwise, yeah, okay, so no, I need to, this is not what I mean. Okay, my, sup, so, okay, uh, sup of this plus plus, okay, if, uh, if sup is 1, so exactly one thing supports it, actually not plus plus, but equals, no, yes, okay. If exactly one thing supports it, then we need to count, so that one cannot be removed. That means, yeah, that's a brick that cannot be removed. And $H of bi plus plus, or actually just some plus plus. Because if this brick has only one support, if this brick, no. Then the bricks that supports it. Okay, yeah. Okay, it's not BI. It's this is H of keys equals keys sub, because the thing that supports it, that one cannot, it uh, cannot be used. Okay, now I need how many bricks? How many bricks we have is at A, because A is the list of bricks, minus percentage H. And that should be the correct answer. Okay, let's see. Line 98. H asks previous declaration. Yeah. What? Uh, where's the previous declaration? Syntax errors. Okay. Yeah, line 90, there's a syntax error. That makes more sense. Okay. Line 99. Okay. Let's see. Wrong. Okay. Okay. This is wrong. That's interesting. So, because to be disintegrated, you need to be not being the sole support of a thing. So, and okay, let's try the sample input, because we have a sample input, so that's good. Okay, 5. Is 5 the right answer? Yes, 5 is the right answer. That's unfortunate, because if 5 is the right answer, I'm not sure what mistake. So let's see what we know here. Let's see. If sub equals y, say brick cannot because of brick 0a cannot be disintegrated because of 1 and 2, which is B and C. Correct. Brick 6 cannot be disintegrated because of 6. That is a problem. That is definitely a mistake here, because, yeah, we don't count itself. Okay, you're not supporting yourself, which also means this would be a problem, because, okay, yep, you're not supporting yourself if defined, and it's not yourself, obviously, because then you're fine. Uh, yeah, that's the problem here. And let's see, so that was the mistake, and the same thing here. If it's defined and is not BI, okay, then you need to do this. Okay, still 5. Different answer. Still wrong. Darn it. Okay, let's see. Break 5. Okay, brick 5 cannot be disintegrated because of 6. Brick 5 is brick F because G would fall. Yeah, okay. And let's see what other we have here. So only 0 and 5. Yeah, so only 0 and 5, which is the correct answer. And 5 cannot be the same. Okay, that is correct answer, but it is not. Let's see what. Let's do a printout of the grid. So I want to do a grid printout, so I'm going to do the following. For my I uh, is normalize okay for is my normalize function good for 3 dimensions? I don't think so. Yeah, it assumes it's 2 dimension. Uh, that's fine. Hmm. Why am I using array instead of a hash? I don't know. Okay. Uh, print g of I, j, k, or dot. Uh, print new line. Print double new line. Okay. Let's see. So x equals 0. What? Okay, yeah, okay. There's way too short. Okay, something is definitely completely wrong here. And bricks are hidden behind other. Okay, so x. Mhm. Why aren't there only 3 lines? Oh, wait. Again, what do we have? Only 3? Why are there only 3 in x? Okay, yeah, there's only 3 values for x. Okay, that is correct. Okay, that is correct. So, oh, mhm. And this is y and z. So, and the bottom z, that's AAA, okay, and then B and C, okay, and then brick 3 and 4 there, okay, then brick F, which is 5, yes, brick 5, brick F, okay, and then GG on top of it. Yes, so this looks all completely right. what happens if I run it on the real input? Oh my goodness. Yeah, so this is ginormous, as you can see. And the real input probably does something that the demo input doesn't do. And so, also, yeah, there are way too many values here, so it's doing silly things. Okay, so this doesn't tell me much because these are so this is the bottom is on the left, and then um, it seems to be okay. There's no reason why this like 593, 593. Fine. So again, which bricks are safe to disintegrate, which means they are do not support other bricks. 5 bricks can be disintegrated. And A minus H is how many bricks can be disintegrated. Right, so I don't even know if it's too high or too low. They don't give me that information. Cannot be, so yeah, go over all of that. Which bricks cannot be disintegrated. And this is, and I'm putting it in a hash, so I'm not double counting. Uh-huh. IJ K minus 1. K minus 1. If it's supported by the ground, we don't care. It doesn't, there's no brick that's the only support for it, definitely. If it is defined and it's not itself, so the thing underneath it is defined and it is not itself, that means this is what's supporting it. If the size of supports is exactly 1, then it cannot be then we have cannot be disintegrate, else uh, every brick must have a support at this point, otherwise we should have kept falling. And then say brick BI is supported by comma keys support. So because so some of the bricks here are supported by multiples, which is fine. That means they cannot be disintegrated. They do not affect the bricks that cannot be disintegrated. And the other bricks we disintegrate. And then 456, and I submitted 456, and it was wrong. Okay. Previously submitted this, yes. So why? Okay. Why is this wrong? I'm not. It worked on the demo input. This. I'm gonna do a silly off by 1 check. Okay. 1 minute. Yep. Okay. Yeah. I'm not sure what to think about this anymore. Yeah, it is doing the. I mean, yeah. Let's actually uh, do it. I want Z to be the rows. Can't do that because silly reasons. Okay. hmm But again, there's no way I can find a problem here. These are surfaces. Actually, each surface. No, I can't do it independently. Like 1073 is supported by 958, which is why it's not falling. 942 is supported by 1342. 539 is supported by 958. Yeah, and only 958, right? That's yeah, and then 958 cannot be disintegrated because of 559. So yeah, I mean, I'm not sure what I can do right now. My code gives the correct answer on the example. It gives the correct answer. Uh, I can change G to be a hash just to make me feel better, but that won't change anything. But it will make me feel better. Okay. I have no idea why this is wrong. I know this is a fool's errand, but I, uh, I'm kind of, I don't know what else to do, so I'm gonna do this. It shouldn't change anything. I've always used defined instead of just a regular check, right? That's one case that I think it could cause trouble. Because actually, do a delete here. Again, it's defined and not equal this one. I've made sure to use defined every time to not have a problem with 0. No, yeah, same day, the same answer, just a different representation. Mhm. I mean, yeah, same answer. Have the again, I delete the thing when I make a brick fall. I delete all the places it used to be. Then I change the Z, changing both the coordinates down. Yeah, and then I put them into. I updated A by putting the new coordinates into A. Then I update G and insert them into G. Let me do some kind of a sanity check before uh, I do any drops, and after I do all the drops. The size of the array, size of the thing needs to be the same. What? Okay. 1388, 4138. That's definitely not the same size. That is weird. Because I'm never. Uh, okay. Okay. This could be the key to solving the problem. Again, just to be clear, this is the two printouts. 1388, 4138. How is the new G way bigger? I'm deleting the same amount of stuff. I'm supposed to be deleting the same amount of stuff I'm putting in. Why is that not the case? Okay, that's concerning. Okay, so there's something weird going on here, and I need to figure out what it is. Because yeah, we're looking going over the bricks, then I'm changing. So unless if it's touch the bottom, I don't care. If it's supported, I don't care. Then I delete the brick, and then I put the brick again. That's supposed to be okay. Okay, so ing keys. No, that. Okay, okay. This is okay. Let's try running it on the simple. 7 and 20. It's also very different. So let's see why. Because they should be the same. 2, 4, 1, 2, 4, 5, 6. Why is there only one instance for every brick here? That's weird. Cause 4, that's yeah, it's 0. Oh, whoa, 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 whoa. That will cause a major problem here. Correct. Okay. One at a time is not fast enough, and you need a chain reaction. Best brick time for each brick determine how many other bricks would fall if that brick were disintegrated. Any other brick, no, the number of other bricks that fall. Each brick is 7. How many other bricks will fall? The sum. Oh, so that's just how many bricks? Yeah, so that's basically what we already counted. It's just because yeah, isn't that what we already did? H of support. Uh, no, it's how many bricks would fall. Uh, so some of these 0 would fall. Now I need. Okay, yeah. Wait again. So turn. So in this exam, number of brick A will cause 6. Oh, total because they will, because disintegrating brick A cause total of 6 to fall because they will be chain reactions of falling. I see. Okay. So disintegrate that brick and see how many bricks would fall. And do that quickly. I mean, uh, so basically this is, I disintegrate that, okay. Yeah, okay. First of all, let me double check that I didn't break anything. Okay, yeah. So, and I need to figure out how many bricks would fall. So, yeah, I'm gonna delete some bricks, so I need the ability. Okay. So now I need to do the following. I need to uh, loop over each brick, remove it, and see how many bricks would fall. That's the I from 0 to A. So the I, right? Okay, do the usual. Wait, put it here. Do the usual loop, uh, and just delete it in this case. Oh, yeah, let's. Okay. So now I need to do a delete G of I, J, K. Just delete it. Then I need sum. Remember it? Sum plus equals fall. And then we need to reset everything. It does reset A to a new value, so that should be fine. G is gtemp. And then just output the sum. Now, this will be slow, but it should be okay. Okay, this will take a little bit, but it should work. Basically, resetting everything, deleting disintegrating the thing, doing the fall, seeing how many. Let me add on the simple. 49 is definitely not the right answer. So let's stop here and see where we went wrong. Did I use some elsewhere? Because no, okay. So 49 is definitely not the right answer. Okay, all of them. That's definitely not the correct answer, and because I put it in the wrong place. Okay, yep. Uh, that means it fell. 7 was the right answer, right? Yes. Run it on the real input. It will be slow, but it will work. Yeah, I mean, I think 1,300. It will be a little slow, but this is fine. I can. I mean, there's definitely a more efficient way of doing it, but yeah, I can basically say if this is, I can because I know the list of supports, so I can just calculate the chain reaction that way because I don't need to. Because if all of your supports fall, then you will fall. So then you can just follow the support graph and figure out. Yeah. But we can do it brute force. Brute force is fast enough. Yeah, my brute force is running right now, 13 and something. So yeah, it should finish in a few seconds, and I can submit it and get my star. Okay.